In the previous video, we looked at the quick energy yield calculation, but here in this video, we're going to be looking at the long procedure for calculating energy yield. So first of all, you need to open a project. And it is this project which has a topography and a layout that you're going to use in order to generate the energy yield. So for every case, you have to open up a project. So we're going to be following the instructions under energy yield. So the first thing you need to do is to open a file titled the WYF file in order to calculate the energy yield. So if you follow these instructions as seen here, you'll be able to see the results of the energy generated in terms of the estimated wind values. So you can view the results on existing and generated data. We are looking at type of listing and graph. So we are looking at the graph. So calculate energy yield for turbine, wind distribution direction, graph. So we are just going through the different listings in order to view the results. Just as the instruction says here. All turbines, wind direction, yield in megawatt hour, energy yield of each turbine. So you need to watch the first video in this series to find out the different files. One of them is the project file. The second one is the layout file, wind turbine layout file that you need to open up. So even based on the anemometers that are installed in this wind turbine farm, you'll be able to estimate the energy yield as a result of the wind energy measured, which is where you have on the right where you have the energy yield instructions. You see view turbulence, multiple anemometer view energy yields. So we continue with these instructions. Turbulence listing. We are selecting the wind turbine that we want to check the turbulence listing for. Total being hours for turbine 4. That's the data present. The interpretation of data is different from navigation in the system. So what we are mostly focusing on in this tutorial is how to navigate the wind farm designer. Power and energy listing. Power for turbines, kilowatt turbines, total power, megawatt, energy kilowatt, gigawatt hour for whole wind farm. So now you need to open the new layout. Open run file. .wfl file. So we want to estimate the energy yield, calculate energy yield from the run menu when finished to the default listing representing the average results will be shown. That's the energy yield as we calculated. So the next thing is going to be view multiple anemometer listings. Listing from the view menu and click OK. The listing will show the total turbine energy yield and average. You can also view the weightings and weighted energy yield. These are the weighted values for anemometers. Multiple anemometer outputs, weighted units. So you can see the weightings that was used: 0.9 to 0.09. Once you sum it up, you are getting 1. So that's how the weightings was used in order to estimate how much wind turbine power is being generated based on the locations of the anemometers. So the next thing is going to be energy yield parameters, which is going to be select edit run data from the edit menu. To see the comprehensive options are available to you, click on the help button to get an explanation of each page. When finished, cancel the dialog. You can look at what each page means. The energy yield parameters. These are the different parameters in estimating energy yield. And you can see here as axis symmetric wake, WASP, flashback, energy balance, as set in turbine data, Garrett Hazard model. So all of these are under energy yield parameters. So once we are done, we are going to cancel the dialog and exit, which is the end of this video. So we have seen how to calculate an energy yield using the long shot method, where you are able to create your own file, your own layout file, and run analysis of wind data in order to estimate the energy range, in order to estimate the power generated in the wind farm. That's it on this video. Thank you for watching this video.